Parity or non-parity are two terms that you will hear when some people and some documentation refers to memory. And in this short video, I want to talk about what parity is, and once you understand what parity is, then you automatically understand what non-parity is, okay? Parity is another way of saying error checking. Parity is really a binary trick that we can use to verify that the data that has been stored in a memory module has remained unchanged, because ultimately when we store data in memory, we're storing that data as zeros or ones, all right? And so if one of our ones becomes zeros, we've made a fairly significant change to the data that's in memory. Now, parity can be described as being even or odd. Now, what do they mean by that? Well, this refers to which bits are used to verify the data. So if you've got 8 bits, let's say, I can use the odd bits. Say I've got odd parity. Well, I'm going to add up the odd bits and going to end up with a number, and then I can set that number, set another bit to indicate what that parity turned out to, what those odd number bits turned out to. Then I can check that later, and if it matches, then I know that none of those odd number bits changed. And I can do the same thing with even, all right? So either the even or odd bits can be used to verify that this data hasn't somehow leaked or changed or been stored in a way that I can't depend on. Now understand, parity is checking for the existence of errors. It's going to flag it and tell us, hey, wait a minute, dude, you're sticking stuff in memory out here, and then when it comes out of memory, it's different. So you've got some memory errors, and you need to take some sort of steps to correct it. So parity will report to me that there are errors. However, it doesn't have the ability to correct those errors. It just reports that a memory error has occurred. So this is kind of cool that it would kind of clue me in that I'm having problems with memory. Because a lot of times what you'll see with memory is you'll start getting blue screens on Windows machines and you can't find a reason for it. Sometimes it's there, sometimes it's not. But if you're ever getting that, check to make sure that you're not getting memory errors every once in a while. And if you're doing that, then change out, put a new piece or a new stick of RAM in there and see if these problems go away, okay? And then other times you'll just straight up get an error message. You'll get a warning that you've got some sort of memory issue, and it'll mention parity checks and so forth. So that's what parity is. It's some binary smoke and mirrors that we're going to use. We're going to count the odd and even bits that are set to 1, and we're going to use that to determine, to make sure that none of these bits have changed. If they haven't, we'll assume that the data is being stored with integrity and it's coming back just the way we put it into memory, and everything should be cool, okay? What is non-parity? Well, non-parity is just when we don't check it that way. Technically, non-parity is going to be a little faster than parity because it doesn't have to go through these gyrations, okay? But generally it's good to have the parity checks going so we can know that our memory is functioning properly and there's nothing goofy going on with the data that we're manipulating and moving around with our programs. So that's a brief little discussion of parity and non-parity. You will see these terms out there in the technological information on RAM. You could see it on the exam, and you could hear it in real life as well.